Hi everybody, we're going to go through our 13.4 misleading statistics. This is a pretty quick lesson, but it's important for you to understand how advertisers and various types of studies can mislead you rather easily. And while I teach through this, I want to put a big huge warning label on. Watch out for the scale and the average that people use. So I'm going to show you some graphs, and you are so welcome to copy these things down, but they can be found in page 704 and 705 of your text. And what I want to do is show what happens when we use a bar graph to influence the way people look at the data. So this table here shows the results of a survey asking 100 kids their favorite drink. So there's milk, juice, soda, and water. So we are going to draw two bar graphs, or I'm going to show you two bar graphs. One uses a scale from 0 to 35 with increments that go up by fives. The other one goes up from 0 to 50 in increments of 10. So our goal as an advertiser is to get kids to drink more healthy types of things. So we are trying to persuade someone that students drink too much soda. So let me give you a quick look at the two graphs so that you can make that determination for yourself. So when I lost my page. And rather than me doing it, I thought the book did a much more beautiful job. Right here, if you look at these two graphs, this one goes up in increments of 5, and this one goes up in increments of 10. If you look at this, here's the soda. It looks a lot taller and a lot more ominous because it just seems to almost want to hit that top here. This one, since our graph hit 50, if I wanted to say, oh, soda's not a problem, I would use this graph. But since we're trying to get kids to drink healthier, say, look at this graph, look how much soda kids are drinking compared to water. We need to close that gap and get kids to drink more healthier types of substances than soda. So you can see just by what increment you go up by can make your graph appear differently. All right, so I'm going to show you another one. Bear with me. We are going to look here, and I want to remind you of the broken scale. This is the example of the bar graph that shows movie ticket sales in the United States for 5 years. Compare the sales in 1999 to 2003. Well, here's the deal. Do you remember this little lightning bolt? I'll zoom in on it. That is the broken scale. So it goes up, and the first number it hits is a 7. This is $7, $7.50, $8, $8.50. But since there were no statistics or entries that were below $7, they started it at 7. So this is what we call a broken scale. The problem that we run into is, notice that it went just below $7.50, and at its highest it went to $9.50. That's only $2 really. But when you look at the size of these, it looks bigger. It almost looks like 2.5 of these would fit into this, but it's only a difference of a couple of dollars. So this scale makes the effect of the movie prices look much more dramatic. And if we read even down here, the total sales in 1999 were 70% of the sales in 2003. Oh, I'm sorry, these are sales in millions of dollars. So $7.5 million almost to $9.5 million. Sorry, I read that incorrectly, but it still stands. It looks like if we would double to triple this, we're looking at $15 to $20 million, and this is nowhere near that. So it makes the amount of money that you earned look more dramatic. So if I were going into my boss, I would want to show this graph and not ones that made it look like it was a slow climb. So the next one that I was thinking of is the movie tickets. Which of these graphs make the average price of a movie ticket in the United States appear more dramatic? Well, it's not a tough question. When you look at it, this line is relatively flat, and this one you can see, okay, it's a little over $5 and it goes up to $6 in 2003. But that looks like a huge slope compared to here. In this one, I'd say movie ticket prices are pretty steady. In this one, I would say, oh, they're going up terribly. So we can skew or kind of make people's brains think differently about the data just simply by how we display it. So we're going to talk a little bit about misleading averages, and I've written down the types of averages again. There are three types of averages. There's the mode, the median, and the mean. The mode occurs most often. The median is that middle number, so you put them in order and then you go zoop to the middle, and if there are two in the middle, you average just those two. And the mean is you add up all those numbers and you divide by the number of numbers. So if there's 3 numbers, you add those 3 numbers up, divide it by 3. If there's 4 numbers, add those numbers up, divide it by 4. So I wanted to show you one here. There's a store owner that says that the average price of a digital camera in the store is $65. The prices of the 10 digital cameras sold at the store are, and look at this. Which average did they use to say that the average price is $65? Well, they're not lying technically, but it is the mode, which is a type of average, and so they were being little sneaky snakes and saying that the average price. So I'm going to go in for my $65 camera, and I'm probably going to walk out with probably $168 to $215 out of my pocket. That's a tricky advertiser. What would the better way to figure this be? We are looking at a mean, and I've already figured this out, of $111 is if you add them all up and divide it. So it's about this one, between 100 and 112, I would say, is what we would walk out with. The median will be somewhere between 95 and 100. So if we go boom, 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 boom. So it'll be about 97.50 is the median, and then the average is 111. Those two together show me it's way off of 65. That is a misleading average. When you go to look at numbers, I'm just going to show you this set of numbers. If you are going to choose a kind of average to use, the problem, once you arrange this in order, is do you see the extremely high number, the 226? That guy is going to throw off your mean. If you add them all up and you divide, that's going to get thrown off. At this point, I do not see a mode. So what I want you to do is realize that you need to be watching closely. You need to watch for the extreme highs and lows that will skew or throw off a mean. For instance, if I normally score in the 70s on different tests, but then all of a sudden I score a 100, that's an extreme high that doesn't usually happen. Watch for those in a set of numbers. Watch for people using a mode that doesn't even come close to the mean or the median. Usually one of these two works really well, unless almost everybody in the class scores a 15, and then there are a couple of 7s, 7, 6, 5, but like 23 kids score a 15. That shows me that the mode is a good one to use. Otherwise, if the mode isn't occurring a lot, I would use another sort of average. Median is usually a great choice, and it helps avoid the extreme highs or lows. A mean works best when all of the data clusters together sort of in the middle. So if everybody does their red hot root words and they score anywhere from 15 to 17, and I want the average, that's a great thing to use. Actually, a median wouldn't be bad either. So this is a simple lesson. watch out. They're trying to trick you, and I want you to watch advertising in general. I would love to give a dojo to anyone who can show me some misleading advertising. Have a great lesson today, and see me if you have questions.